My name is Michael Hausenblas. I'm a developer advocate at Mesos, and today I'm going to talk a bit about automation. First question, who of you is using Slack? All right. Who of you noticed that yesterday evening there was a 2-hour outage? Okay. You're the only, well, I did. So who of you knows IRC? Good old IRC, yeah. So Slack is kind of IRC on steroids. So you get to chat with your colleagues, and you can upload stuff and whatnot. And I'm pretty dependent on Slack because I'm pretty much every week on the road, and the only kind of connection with my team is Slack. So I did notice, and I said, hey, Slack, how about you fix that, get your act together? And by the way, we offer something that avoids downtimes. And in fact, I'm going to use our product later on to do a demo. But before we get into that, let's have a look at a day in the life of a container. So we start on our little machine, on our dev laptop or whatever, some features. Business says, implement X, whatever that might be. And obviously they're always late, and we're always under pressure, and we need to get that out as soon as possible. Next, we go through, I labeled it testing, but it really is a bit more than testing. But usually you might expect nowadays that you have a CI/CD pipeline, continuous integration, continuous delivery. Who of you has a CI/CD pipeline? Awesome. The rest of you, why not? Okay. So I will be around later on at the open space and until Thursday. So the people who have not raised their hand right now, please do come and speak with me. I'm not selling CI/CD pipeline software or whatever. I'm just curious. Next, if we are conservative, some of them say you live only once. We directly put it into prod, but typically you have a QA environment where you're staging, and then you put it into prod. You're live, and you're making money, hopefully. But as with every operations, there are bugs, right? And that's probably the boring part, right? You always like to do new stuff, new features, and all the bugs. That sucks, but still, that's the input we get from a developer point of view, right? We get the bug reports here, fix that bug, and we get some new features, and that cycle starts again. So far, there's nothing specific to containers, but in each of these phases, I could map that to a container. So you could, for example, say in dev, it would be developing your app and then packaging it as a Docker image, putting that into, let's say, for example, Jenkins, as we have them out there. And then you have, for example, a cluster, a smaller part for QA, and probably a bigger part for product. And maybe you're also doing the development in parts of the cluster. Anyways, the big advantage with containers is that you can guarantee that throughout the entire life cycle, your environment is always the same. And I always get a bit nervous and allergic when people compare containers with VMs, because that's not what they are. What they really are is a very nice way for us developers to package up the environment and to do a kind of application-level dependency management that we can use throughout the entire life cycle. So it's not about virtualization. There is some isolation there, yes, but that's certainly not the big thing. So with a few commands, Docker build, Docker push, Docker pull, and so on, Docker run, I can essentially cover the entire space, and there's a lot of tooling around that automates a lot. Any questions so far? Please do interrupt me. If you have any questions, comments, please do interrupt. I take questions both in German and English. I'm from Austria, so I do understand German, and theoretically also speak German. Now, this is our product. I'm not going to give a product pitch, just to give you a bit of an orientation what we're doing so that you can appreciate the demo that follows in a moment. Whatever kind of infrastructure down there, we just see them as boxes. You could have something bare metal, on-prem, whatever. You could have an instance in the cloud. We don't really care as long as we can install an agent there. We're using Apache Mesos, which is a Apache Software Foundation top-level project. And essentially, it's a resource manager. It abstracts the resources, CPU, RAM, ports, disks, whatnot. And to you, from a developer point of view, your entire data center, your entire cluster, imagine 3 racks with I don't know how many machines. It looks to you like one big computer. I always say cheekily that this is kind of mainframes done right, and I hope no one from EMC is around here to hit me, or someone from IBM, so sorry for that. But it really is, from developer point of view, this is what it really does, right? To you, this entire cluster of machines looks like one big computer with so many terabytes of RAM and so many petabytes of HDisk drive. Okay. And this is really our app store up here. So you see there are things like Jenkins and Hadoop and Spark and Cassandra and Elasticsearch and so on and so forth. And that is where we essentially bring the value in. Like, if you want to use, and I'm going to show later on a demo that uses Spark, InfluxDB, Kafka, and a few other things. If you want to build your application, a bit like in the App Store where you download something, you can just combine these different infrastructure services effectively with one command line, and you can pick one and I just install it. And depending on what it is, some of them obviously need a bit longer. If I install Hadoop or Cassandra, just to set up the whole thing, it takes between 5 and 15 minutes. But that's just the way these storage services work. Can't do much about that. Any questions so far? So we have some infrastructure, and that is what we bring to the table, right? So, look, Ma, I fixed Slack. So what we're going to do is, I looked at that and I said, I meant that tweet to a certain degree serious. Can we actually do better? I'm not sure what they didn't really reveal what the root cause was, but I think it was some, they pointed to some external networking service that went down. It's always good to blame others. And I thought, maybe we find some open source version of Slack, and indeed it exists. It's mattermost.org, and we're going to put that, we're going to deploy that on DCOs. Okay? Let's do that. Excellent. Now, what we have here is, first of all, the DCOs. So that is the kind of visual interface that ops guys would see. They would see the nodes. So we have 4 nodes, 3 private nodes, and 1 public node under management here. And I have Marathon installed here. I'm going to talk about Marathon in a moment. And overall, you can see this is what I mean by we make, or Mesos and the DCOs makes your entire cluster look like one big machine. So we have total, we have some 16 CPU shares, some 55 gigs of RAM, and so far, thanks God, no failures yet. The other part, how you would interact, I mean, I really appreciate the work that our designers put in there, but typically, like you and me, you would probably use the command line to script stuff, right? So let's see what we have installed here, and hopefully it also says, well, nothing, because Marathon is part of the system. But if I would go and install, let's pick something for now that completes once we're done with the demo. Let's say Cassandra, why not? Right? So this is how hard it is to install Cassandra on the DCOs. Yes. Okay, now it takes a bit. It really takes a bit, like 15 minutes. Oh, it's already there. I don't believe that. Nah, it typically takes some 50 minutes to set up the whole ring. Yeah, unhealthy. So it's still provisioning, right? It might have returned, but it's still, until it's available, it takes some 10, 15 minutes in my experience. But you do see the overall utilization going up, right? Blah, blah. But that is not our demo. The demo is really about fixing Slack, right? So what we've got here is a Marathon app spec. I don't know if you can see that down there in the back. Can you see that in the back? Yes? Okay. So this is an app spec, and don't ask me why my validator orders it by alphabetically, I believe, yeah. When I write it manually, I mean, who writes JSON manually? But when I write it manually, then I put the ID first, because that's the thing that really matters in the first place. So you've got an ID here. So what you're saying with that is, dear Marathon, which is, think of it like a distributed init. You just say, I want to run this web server or whatever Docker container forever, and Marathon takes care of that. As many instances as you tell it will run in the cluster. And you do that through this app spec, and the most important bits here are the ID, so we will refer to that as MM, which stands for Mattermost. You can specify resource requirements, so in that case we say, please, dear Marathon, and by extension Mesos, give it 1 CPU share and 2048 megs of RAM. And that actually, when I first tried it out, is necessary because Mattermost with the 512 that I started with just wouldn't come up. So it requires a bit of RAM. And then I say, okay, look, I wanna actually, because I'm lazy, I don't want to install stuff myself, I'm actually gonna launch this Docker image here, Mattermost/platform, and I'm gonna expose this port 80 to somewhere. So that's the Marathon notation to I don't care. Marathon will pick, or Mesos actually will pick a, whoops, that's dangerous, some random port in the range, and I gotta look that up, and there you already see with this dynamic port allocation that one of the challenges in this dynamic environment is actually service discovery. So not only figuring out on what node, on which IP Mesos decided to schedule it, but also on which port, because as I said, I don't care, right? Why don't I care? Well, because if there are many of those, they will compete, and not everyone can be on port 80, just one. So good practice would be to say, I don't care, give me one, and then you somehow need to figure out which one it is, which is service discovery. This up here, you can ignore that. That's just, I need to do that for demo purposes because I only have one public node. And only this public node is routable, which means I can open it in a browser. So this really means, dear Marathon, I want to ramp up this Mattermost platform, Docker image, expose port 80, give it 2 gigs of RAM, and schedule it on the public slave. That's it. Right? So let's launch it. DCOs Marathon app add, and then I give it this JSON file. And hopefully, if I have appeased the demo gods, I should see the service coming up. Yep, that's here. Actually, let's look into Marathon itself, and we should see. Yeah, there you go. Cassandra is still provisioning. So it has exposed it here. That's the port it has picked. I don't know if you can see that. 31090. And now I need to look at my cheat sheet what the public IP of that slave is. Okay, what was it? 3109? You live only once now. Of course not. 31090. Okay. Almost there. Now, what happens is, hopefully, that Mattermost comes up, and I'm going to sign it. And, you can go there. That's publicly routable. You can, I can't hold you back that you enter 52.33, 192, 174, 31090, and also sign up, right? I can't help to do that. I love signing up. So I'm going to create a team. The team is DevOps Con Awesome. Okay. Screw you. Yeah. Okay. We're awesome anyway. So. Okay. There you go. Yeah. As usual. Okay. That's it. So now we have our open source Slack clone. You can go there. You can sign up. Just waiting for the first private message. Hopefully it's safe for work. Be aware you're being recorded, so careful what you're saying. What do you think? Why is that not yet production ready? It is. Like you can all use it, and to whatever extent the 2 gigs and the MySQL database can handle it, it will handle the traffic. But what if I would here say scale up to, let's say, it's so popular that I want to have 10 instances of that. Why would that not work? Any idea? Well, no, with that config it won't work. If I would remove the constraint that it has to be on that host, it would scale, but what is the problem? Again, I tell you, it has a MySQL database, an underlying MySQL database. Sorry? Yeah, you're in the right direction. So what it doesn't do for me is it doesn't do auto-sharding, right? It launches 10 separate instances, but it's not like one big thing. It's like 10 instances of what I just did, right? So I would have 10 different times the DevOps Con team and so on. So what is necessary, this is really dangerous, what is necessary then would be to use, for example, we have, I think memSQL is there, to use something that offers the same SQL interface to, in that case, Mattermost, but really is a distributed SQL database. Or I manually shard the thing. So I can launch the MySQL containers, or whatever. It doesn't have to be a container marathon. Can also launch just everything you can launch from the shell myself and do the sharding manually and then bring it together on the application layer. I can perfectly slap some load balancer in front of it. It just, on the data layer, Marathon or Mesos, or for what it's worth, any other container orchestration system doesn't give me this handling automatically. So I can use distributed file systems, Cassandra or whatever, but I need to take care of that myself, right? Okay, any questions regarding that so far? Straightforward enough, right? Okay, so fixed Slack, beside this minor issue that I need to shard my database. Now a very quick introduction, interlude to container management, and I in fact also suggested a open space discussion around that, so happy to continue it. This is what a scheduler does, and if you don't have one, then you are the scheduler. Someone, your user, that might be a developer or whoever, says run this app on this cluster of machines. And again, if you don't have a scheduler, you are the scheduler, or your colleague in operations. So the function is finding capacity in the cluster to launch a certain app, fulfilling a variety of constraints. That could be utilization, that could be preferences in terms of this app can only launch on an SSD-backed device or whatever. And then keeping those apps up and running, right? So if for example, the process goes down, some heavy garbage collection takes place or whatever, and that app goes down, the scheduler says, hey, actually, I was asked to run 3 copies, 3 instances, 3 replicas, depending on which scheduler you use. There are different terminologies, of this app, and I only have 2 because one of them went away, because of whatever. So I need to launch a third instance or third copy of that app again. So we're going to talk about this part here, right? Because this really sounds like something that a software can perfectly do while using a human there. Before we could do that, quickly a look at workloads, because there are really widely varying degrees of, like, there are workloads and the requirements that come with these workloads, scheduling these workloads vary a lot. So we have batch things, Chronos in our ecosystem, good old MapReduce. We have Spark, which is actually a batch, micro-batch core architecture. We have Flink, which is, by the way, also European and German rooted, I would argue. We have Storm, which is really core streaming, Samza, and then we have Marathon, Kubernetes, and others in this PaaS, low latency, long-running service space. And ideally, we want to be able to schedule all of these tasks, these varieties of tasks within one cluster with one scheduler. If you want to learn more about that stuff, I can recommend you the Borg paper that came out this year, Google Borg, where they talk a lot, also the Omega paper that came out 2013. But Borg has more details about different requirements and strategies how to deal with variety of workloads. So the next two slides are from my upcoming book, Docker Networking and Service Discovery, a really short book, just 55 pages. And we can argue about these pluses and question marks and whatnot until the cow come home. But here is what I've seen so far in terms of production use cases and what I hear in the field. Essentially saying that if you have only a couple of nodes, you have a lot of options. The further you go to the right, the more nodes you have less and less options that are reliable, scalable at scale. This is a slightly different point of view, not in terms of scale, but in terms of which kind of workloads the respective scheduler or orchestrator supports. And if you are fully containerized, then yeah, you have all the options. If not, then you're to a certain degree limited. One thing that really stands out is this last one, and I alluded to that already earlier on when I told you about this problem that I have with this Slack clone, with this open source Slack clone, and this turns out to be a general problem with schedulers. The Googlers that wrote the Omega and the Borg paper had this academic freedom to just ignore this space and say, yes, we're doing it. Recently, last week, talked with John Wilkes, one of the main authors there, and I also didn't get a lot of deeper knowledge out of him. So essentially, we don't really yet know how to deal with that at scale in a reliable way. A lot of hand-holding is required, a lot of out-of-band managing of stateful services. So anything, databases, distributed file systems, whatever, in a containerized setup is not trivial. Summing up, and with that we complete this interlude. Ideally, you're using one of those guys, Kubernetes, Mesos Marathon, or Nomad, which is HashiCorp's new kid on the block, which is much better, much better than writing your own container manager, which again is much better than manually managing containers. So you don't want to be that poor fellow who sits there and launches some Docker run on this machine, SSH into the machine and then Docker run. And you also don't want to be the guy who writes a container manager. Do use one and extend if you want to one of the existings. Okay, now let's have a look at a more complete example. I'm not going to show that because it takes a bit longer, a bit more time than I've got, only 20 minutes left. But there's a blog post, everything is up on GitHub, so you can try it out yourself. You don't even have to use our DCOs, you can use essentially all of these components are separate open source projects, so you can just download them and together with the code in our repository, set it up yourself, just to walk you through and to give you a bit of a feeling and idea what we did there and why we did certain things. So this is a demo, and you can't really see it nicely, I would say, that uses some crime data, CSV dump of some 500 or 600 megabytes from the city of Chicago, and essentially has both timestamps and geocoordinates in it. So it says, at this point in time, at this location, a battery or a robbery or whatever happened. And this data is interesting. Why? Because it has both the temporal and the spatial dimension. What we do with that is we essentially read every line in the CSV and spit it out, one record at a time, and that essentially makes it a kind of synthetic stream source. We pump that into Kafka, and Kafka, who of you know Kafka? Okay. Kafka, you might know Rabbit or ZeroMQ or whatever. Essentially, just think of it as a big queue, which happens to be a persistent queue, which means Kafka writes it directly to disk. Retention time, I think, per default is something up to 24 or 30 days. And it's really, really fast. So you can have high throughput, persistent PubSub-like behavior. And it really, like the guys at LinkedIn developed it essentially to decouple their publishers and consumers. So they have a lot of different publishers. If you click on something like, I like that new job or whatever, that's one publisher. And consumer would be, I don't know, how many people viewed your profile or whatever. And they wanted to decouple these many publishers and consumers, and that's why they wrote Kafka in the first place. And you can use it, and it is very often used. In the meantime, there's a commercial entity behind that, Confluent, that provide services around that as well. You can use it whenever you have big data, for whatever definition of big data is, and to do exactly that, right? You don't want to lose any of these messages. In our case, it would be trivial, which would just replay it. But imagine this is live, real data from sensors or whatever. You really want to make sure that no matter what downstream happens, like Spark or Storm has a bad day and might not get everything, you really want to make sure you keep all the messages around, and you can also replay. So if you say like, okay, I'm going to upgrade here something in Spark, you can just say, okay, give me from this point in time, that's the last thing I've seen and processed, and again until now. So we've pumped the data into Kafka, and from there we have a Spark streaming application that on one hand it reads out one message after the other. On one hand, it ingests the whole thing in this, what we call the online part, and on the other hand, in this offline part. The online part, we'll tell you in a moment why this is actually bullshit, because online and offline, because it's Spark streaming, both is online, was an architectural decision early on. We thought we were going to do something offline as well, and then we didn't bother to change the labels. The online part, essentially, InfluxDB, who knows Influx? Okay, time series database, so indexed by the timestamps. Spark ingests the events or the messages into InfluxDB, and then you can view it in Grafana and see how certain crimes evolve throughout the day. And there the retention period is just an hour or whatever. So this would be for someone, think about police dispatch or whatever. You sit there and you see somewhere a spike. You might be able to correlate that with an event, like let's say a soccer game or whatever. And you can, based on that, maybe dispatch some units somewhere. So this is the online part, which only looks at the last, in this case, 1 hour, or it could be 5 minutes or whatever is relevant to your use case. So this is like what is happening now. The lower path here that we stupidly called offline part is essentially looking at the data in its entity, the entire 500 or 600 megabyte. So it has an aggregator function there. The Spark streaming function aggregates the data and essentially pulls out the geolocation, which then can be used in an overlay heat map to show where are hotspots, and that might be useful for planning, like, or if you want to buy a house, you see like, oh, that's a dodgy area. I'm not going to buy a house there. And you might notice, you might not notice this logo here and this one, but I'm going to tell you, this one up here is Marathon, and this one down here is Kubernetes. Why did we choose that? Very simple. We could have chosen Marathon for everything or Kubernetes for everything. In this demo, it wouldn't have made a difference. But we chose Kubernetes here to demonstrate the unique feature that is Kubernetes unique, which is a pod, and the pod being the idea of having certain containers working together so because Kubernetes has as a unit of scheduling a pod, and the idea there is that you have containers that belong together, that work together on one host. Now imagine if we wouldn't have done that with Kubernetes, but Marathon, for example, or Swarm or Nomad or whatever, then this container, which is the S3 fetcher, which just goes to a bucket and downloads that file, that JSON file, onto the local hard disk drive, and this Nginx container, which essentially just renders this JSON file, they would be on two different. They would end up, potentially, the scheduler could decide to schedule these two containers on two different nodes. That would suck, right? Because the S3 fetcher would write it locally to this one, and the Nginx container wouldn't have anything to display, right? So we really want to make sure that these two containers are scheduled on the same node. And a pod trivially does that. A pod is exactly this idea of having different containers that somehow work together on one machine. You can somehow do that with Marathon constraints, but it's a pain in the neck. Okay, any questions regarding that demo? As I said, there's a blog post I wrote, there's a GitHub repository, you can download everything and try it out yourself. Any questions? Clear as mud? Okay, perfect. Okay, now we get to this, okay, here are things that are nice to look at and so on, like, you might look at that and go like, that's nice. I mean, you get paid for telling that shit. Like, how do I do that? Where do I start and how do I start? Thanks to Kalashnikitty, our good old friend there, we have a number of things, and the most important one probably, for no matter if you're technical or not, is get that book and read it if you haven't, and get it for your birthday or for Christmas or whatever for your colleagues or your boss. I'm not sure if you're going to give your boss something for Christmas, but Phoenix. Who of you do not know about the Phoenix project? You don't have to have read. Really? Okay, cool. So, done. Right? Read that, understand that, apply that. That is why we are doing DevOps. Right? That is why it makes sense to actually look at all this tooling. And what I'm trying to, convince people out there, especially management, CIO, CTO level, is, look, it's not a tooling, technology, whatever challenge. It is, to a big, big degree, a social challenge, a challenge that is, how are we, dealing with each other between, the good old way of, I'm a developer, I throw it over the fence, and now it's your problem, versus we're all in that together. And I mean, Amazon is well known for that. This principle that you as a developer, you're also the one who is operating that, right? So you get paged if your app is down. And I'm actually trying to establish a new term for that, not DevOps, but AppOps. So you're not the one who is replacing a cable or a rack or whatever, but you're the one who is actually not only writing the application, but also operating it. You're the one who is responsible for keeping it up, and you're the one who will appreciate the scheduler who does the dirty work for you, and you only need to take care of things like rolling upgrades and health checks and so on. If you're very new to Docker, these are probably the two best books. You might want to start with this one and then this one. This one has an awful lot of really, really good advice in there, but you can't really learn Docker from it. On the other hand, what is there to learn? Docker run, Docker build, Docker pull, done, right? So there's not that much to learn. But if you want to start with that, and then this one is also a very good one. If you're into Mesos, this is from a colleague of mine, this is from a friend of mine. I don't get any shares there. It's just I like both books. This is more for developers writing frameworks and so on. This is more for ops guys. And there are a couple of Kubernetes-related books. Kelsey Hightower's book, free O'Reilly book around Kubernetes, like 30 pages or whatever, and my upcoming book around networking and service discovery, which also has Kubernetes and Mesos and so on and so forth chapter. Both of those are free anyway, so you can get them without paying. And we've put together two advocacy sites. The one is p24e.io, which stands for Programmable Infrastructure. That's why 24 is much nicer to say than Programmable Infrastructure, which is essentially a collection of like keeping you up to date of what, like every week someone open sources something, and to keep up with all these developments is pretty hard, and we want to make it easier. And the other part of that is our guidelines. So if you want to know how to do service discovery with Mesos DNS and this and this and this, there are guidelines there. And actually, I would like to encourage you, because it's backed by a GitHub repository, to send in or share your recipes, your guides with it. So please send in a pull request and make the site better and everyone's life better. And last but not least, a Kubernetes advocacy website I recently launched, community resources that contains tutorials and a few recipes to bootstrap stuff. And with that, I lead over to good old William Shakespeare, and I hope we can agree that this is not a question, but maybe you have the one or other question for me. Thank you. So we have some 10, 15 minutes, I believe, for questions. I'm pretty sure Liz has a question. You have a question. You look like you have a question. It was not the same talk I gave. It's not the same talk I gave last week. It's entirely new.
How would you characterize the difference between DCOs and marathon research? What does DCOs add over top?
Got it. So the question was, what is the difference between DCOs, so our product, and Mesos Marathon standalone, essentially? So the funny thing is, you remember maybe last week when Patrick Riley from Kismatic asked me the same question around Kubernetes and DCOs. I was trying to avoid talking too much about the product. We can do that on a one-to-one basis, but essentially, our idea, or the idea of our founders, was to take the operational knowledge they had running Mesos and Marathon and Kronos and a lot of other frameworks at scale, at Twitter and Airbnb and other places, and trying to turn that into a product, which makes it very easy. Things like what we've seen there earlier on, this DCOs Marathon app add, yada yada, or DCOs package install Cassandra, right? That is something that we add to the whole thing. We have repositories, and you can think of that like the App Store, essentially, right? So if you look at the universe, you will find all these different repos there for Kafka and Marathon and so on and so forth. And the same, so that's the kind of stable. Don't ask me, whoever came up with these names. Universe and multiverse, and here you say a lot of packages from Zeppelin, React, and whatnot that you can also install, but they're not vetted yet. They're not through this certification circle. That's another part, this certification cycle. That if someone, you can send in a pull request and say, I've created a Mesos framework for whatever app, Angry Birds or whatever, and it will land here. But this is not a guarantee that you can say DCOs package install Angry Birds, because there we still want to make sure that it fulfills a couple of requirements, and they are laid out, right? So there are a number of service availability. So you see prod ready is Kronos and Marathon so far, where ArangoDB, which is actually a German-based company, Colon, I believe, yeah. A couple of others are in beta, alpha, and there are many, many more who are, we need to work together with our partners to get those higher up there into prod. And that is what, so the UI, so this bit, right, the command line interface, the repository, this kind of, the whole thing that allows you to just deploy and launch stuff very easily, that is our offering. That is what we bring to the table. There are obviously a number of companies, including Apple, for example, that they roll their own Mesos stack. They take Mesos and Marathon and whatnot. They hired at least one of our engineers so that they can do that. Yeah, that happens. It's open source, right? It's the same as with Hadoop in 2008 or 9. At some point in time, probably people might say, well, it's not really my core competency to set up a Mesos cluster. I want to use it, but not set it up and frameworks and whatnot. At least that is our hope. And does it make sense? And thank you for the question. I did not pay Liz. I did not pay Liz. Yes, please. The sir with, yes. Sorry, can you stand up and shout? I don't hear anything. Hi.
Why you didn't mention Fleet from CoreOS as a tool to manage nodes?
Right, because CoreOS, sorry, the question was, why didn't I mention Fleet from CoreOS? Because CoreOS said Fleet is dead. Is that enough? Or? So CoreOS at some point in time decided they're going to go all in regarding Kubernetes and declared, I can look it up for you if you want, or you type it in Google, that Fleet is dead. They consider Fleet not as the future, they consider Kubernetes as the future. That's why. Make sense? If someone from CoreOS is here and wants to say that I'm a bloody liar, please stand up and tell me so, but that's what I gather. And I think it was the CTO of CoreOS who told me that. Any other questions? Everyone eager to get to the beer. I get it. Me too, no worries. So as I said, yeah. Yes, please. Right. So I don't know about the like normal case. In case of the DCOs, I might actually, well, I don't know if we have that much time, but it's effectively, because it's currently in the multiverse, you need two more things. So you need to first do that, right? So you need to make the DCOs command line interface know about the multiverse. You need to do an update, as with every other package manager, apt-get update, blah, blah, blah. It will pull half of the internet. And then, that wasn't the case before the previous version, you also need to do that, yes. And then, what? Yeah. And then, no, I'm not going to do that. And then, I need to do that. Okay. Screw you. What was that? Options.json. No boost for using Nano. Usually on an ops conference, I get booed out of the room for using Nano.
But why did you touch it before?
I'm so used to that. I'm sorry. And now I need to do. I like to touch things. That's right. And now I need to add that. Oops. Sorry. Now I need to add that. Yes, still yes. And now we should have kube control ready, right? It takes always, a minute or two. For stateless stuff, shorter, but whatever. So while we're waiting, okay, DCOs, kube control. Need to download the kube control thing. Cannot download from, Well, let me see. No, I have network, right? I still have network here, I hope. I have to touch it. No, I do have network. No, that must be... okay. I should wait until until Kubernetes is actually provisioned. I'm always a bit too fast, so I need to wait until all the nodes are there, until everything. Once I see that, yeah, it's not found yet. So it takes a couple of minutes until everything is set up. No, still not there. Now the nodes come up. The pods are there. Yes, now the kube control will also work. And yeah, and now you have, I don't know, you probably don't see it down there. I'm going to get it up in a moment. So yeah, so it used to be like one step, and now it's like 3 or 4 steps, but you know, it's get nodes, right? Oops, sorry. Yeah, get pods will be empty, right? No pods yet. So yeah, so does that answer your question? Right. Any other question? Not the case. Okay, so I will be around, as I said, until Thursday morning. Happy to spin up a cluster or two as quickly as 30 seconds from our pool. And if you want to see something, anything, as I said, some of the services, HDFS, Cassandra, take a bit longer, but in average, a couple of minutes, and we can deploy stuff. Thank you very much.